This is chapter 8.6, a lesson on solving logarithmic equations. When we want to solve a logarithmic equation, our goal is to make it as simple as possible first. So, for example, when I have one log, I know I'm going to be ready to solve. The next thing I'm going to want to do is, if I have exponents in my logarithm, it usually makes it easier if I bring those to the front and use that power property. Then I can divide the coefficient away and I get a much easier, simpler problem to solve. And from here, once I get it down to one logarithm, then I'm going to use my exponent form to solve it. So I'm going to start with the 2 and I'm going to say 2 to the third power equals x. And if I solve it, I get x equals 8. And at this point, I want to check and make sure that my answer is in fact going to work. And really, the biggest thing I'm going to look for is when I plug in 8 in for x up here in the original problem, as long as I'm not taking the logarithm of a negative value, that solution should hold true. So if I double check, do a little mental check, I'm still logging a positive value, so I should be okay to go. In this next example, again, I have this coefficient out in front of a 3. So the first thing I'm going to do before I even start to put anything in exponential form is I'm going to solve for my log. I'm going to get my log alone. And then at this point, I'm going to put it into exponent form. So I'm going to start with the base. 5 to the second power equals x plus 1, whatever I'm taking the log of. 25 equals x plus 1. And now I'm going to get x by itself. Sometimes we have that little extra step, x equals 24. And again, I'm just going to make sure that I'm not taking the log of a negative value. When I plug that in, I should be taking the log of positive 25 eventually, and that means that my solution should hold true. Again, when I solve a logarithmic function, if the log is not alone, I need to get it alone. So here I have an added 5, so I'm going to get rid of that by subtracting 5 from both sides, and I get the natural log of x equals negative 4, and the natural log has a base of e. So I'm going to remind myself by writing in the little e, and when I put it into exponent form, I'm going to say e to the negative 4 equals x. And if I plug it into my calculator, I can also get an approximated value of 0.018. And we're always going to round to 3 places. So there's my reminder, round to 3 places. The next example we'll do involves condensing logarithms down. So if I have multiple logs, what I will do is I will use my product or my quotient or my power property and condense it to one logarithm. So here I have addition. Addition will condense into multiplication. So I'll multiply 8 times x, and now I have one log. Now I'm ready to put it into exponent form. And so I'll start with the 4. 4 to the third power equals 8x. And then 4 to the third power is 64. And when I solve this equation, I get x equals 8. And again, I'm going to check and make sure anywhere there's an x, I need to plug it in and make sure I'm not going to take the log of a negative value. So this example holds true. 8 is my answer. Here again, I have 2 logarithms. I need to condense them down. So I'm going to condense them down to one logarithm, and I'm going to multiply x times x plus 3 equals 1. And now I'm ready to put it into exponent form, and the base of the natural log is e. So I'm going to say e to the 1 equals x times x plus 3, and I'm going to distribute, and I get x squared plus 3x equals e. And this is a quadratic function, so I need to get it ready to use my quadratic formula. And here a is going to be 1, b is 3, and for c I have to use negative e. So when I plug it into my quadratic formula, it will look like this. So I've plugged it into my quadratic formula, and I have simplified that square root of the discriminant with the b squared minus 4ac, and I get it down to this point. And here, just recall that when we use the quadratic formula, we're going to split it into two answers. One of them is negative 3 plus 4.458, then divided by 2. The other one is the subtraction, and when we evaluate both of those answers, we get these two solutions. We get 0.729 and negative 3.729. And remember, we always want to make sure that if we were to plug this into the calculator, we want to make sure we're not taking the logarithm of a negative value. And if we plug in 0.729, it's going to work. But if we even tried to plug in this negative value here into our natural log, we would get a non-real answer. And so this is called an extraneous solution. It's an extra answer that isn't really an answer, and so our only answer is positive 0.729. And here we have one last example involving the same concept here. We're going to condense into one logarithm, log base 3 of x times x minus 2 equals 1. And once we have it down to one logarithm, we want to write it into exponential form. So 3 to the 1 power equals x times x minus 2. 3 equals x squared minus 2x, and I have an x squared, so that tells me it's a quadratic. So I need to get it equal to 0, and then I can either use my quadratic formula, which is always a very good fallback, like we did in example number 6, or this one, if you'll notice, will actually factor quite nicely. So in order to factor, I'm going to say 0 equals, and then I'll have x times x, and then things that multiply to negative 3 would be 1 times 3. One's a positive, one's a negative, and if I think about how I need to have them add up to a negative 2, I'll know that my 1 and my 3 go just like this, which leads me to the solutions negative 1 and positive 3. But again, we want to check and make sure we're not going to take the log of a negative value. So when I check both negative 1 and 3 into my original equation, into both of these x's, negative 1 will not work. It makes me take the log of a negative. So the only answer I have right here is positive 3.
Made with Doodlecast Pro.